Hello, welcome to chemistry class. My name is Odusonya Olalekon Adiola, and this video is brought to you by Igotha Virtual Learning. In this lesson today, we are going to be looking at the structure of atom, part 1. The structure of atom is one of the most important and foremost topics in chemistry because it exposes you to the fundamental and the foundation of every chemistry topic you come across. It's talking about atom. Atom is the foundation or is the starting point of all elements, compound, mixture of all chemical reaction. So it is important that we look at the structure of atom. In this video today, we are going to be looking at what an atom is. We are going to be looking at the history of atomic structure development, and in that history we are going to be looking at John Dalton's atomic theory. We are going to be looking at J.J. Thomson model of atom, and a Rutherford model of atom, Neil Bohr model of atom, and with Schrödinger model. And then of course we are going to evaluate you at the end of the session and give a summary. So let's look at what an atom is. An atom is the smallest particle of an element that can take part in a chemical reaction. When atoms come together, they make a molecule or particles. Of course, there are many different types of atom, each of them having their own name, their mass, and their size. And of course, atoms can be electrically charged such that they become ions, and as such they can be positively charged or negatively charged based on if they accept or gain electrons, as the case may be. So generally the definition of an atom is the smallest particle of an element that takes part in a chemical reaction. Now let's look at quickly the history of the atom timeline. Dalton and Democritus started. In fact, Democritus started the talking about a lot of scientists have worked on atom, but Democritus started. But the first work of atom was credited to John Dalton, who was able to explain the indestructible and indivisible particles called an atom. He was also able to prove a lot of mention few things that studied the structure and the behavior of atom at that time, carrying out a lot of experiments in that process. Immediately after Dalton, we have the J.J. Thomson that gives a model of an atom, and in the process was able to discover cathode rays, which have some specific property. We are going to be talking about this later. Then after Thomson, we have a student of Thomson, Ernest Rutherford, coming up with his own model that modifies the model of Thomson, and was able to give us a better view of how an atom is. And then after that we have Neil Bohr. Neil Bohr was able to substantiate the claims of Rutherford and give a better explanation to it. Then after Neil Bohr, the structure of atom was very clear. Other scientists also work, Emil Schrödinger, Max Planck, and others. They were able to work on different calculative parts, giving us some quantitative value about atoms and its subatomic particles. So this is generally the history of atom, from Democritus to Dalton to Thomson to Rutherford to Neil Bohr and other scientists after that. So we are going to be looking chiefly on Dalton's, Thomson, Rutherford, and Neil Bohr's model or theories of atom. Okay, quickly let's start with John Dalton. John Dalton was a British school teacher, and he made some postulates that were very vital in his model. Of course, you will observe that when we started, this was his model then. Now, you observe that we said each of them have an idea based on experimental values and some of the experiments they carry about what a shape or model of how an atom is. So, John Dalton proposed what is called a Bohr model. He proposed what is called a Bohr model. He said that an atom is a uniform solid sphere. He said that an atom is a uniform solid sphere. Now, in his model, he was able to come up with some theories. I'll put some of those theories here. They are not here. Like I've said, he said his model is called Bohr model or billiard ball model. Please take note of that. You can call it a Bohr model. You can call it a Bohr model, and in that Bohr model, he said an atom is a uniform solid sphere. Now, he also have theories to prove this. He postulated some theories, and he said that all matter is made up of tiny, indivisible particle called atom. You can also put that first theory like this: all elements consist of atoms which are indivisible. That's his first theory. In the second theory, he says atom can neither be created nor destroyed. That's the second theory. The third theory, he said that all atoms of a given element are alike, but they are different from the atoms of any other element. Number 4, he mentioned that compounds are formed when atoms of different elements combine in a fixed proportion. Compounds are formed when atoms of different elements combine in a fixed proportion. You can put that theory this way as well. You can say that when atoms combine with other atoms, they do so in simple ratio. When atoms combine with other atoms, they do so in simple ratio. And then the last of his postulates says that a chemical reaction involves the arrangement of atoms, not a change in the atoms themselves. A chemical reaction involves the arrangement of atoms, not a change in the atoms themselves. You can also put it this way, that all chemical change result from combination or separation of atom. So this is the Dalton's atomic model. This is Dalton's atomic model. So we have talked about the Dalton's atomic model. The Dalton's atomic model as Bohr model or billiard ball model. And in that Bohr model, it says that atom is a uniform solid sphere. John Dalton said atom is a uniform solid sphere, and he come up with, based on his experiment, came up with about 5 postulates, which are called Dalton's atomic theory. Now, quickly, let's go to the J.J. Thomson model of atom. The J.J. Thomson model of atom. In 1897, J.J. Thomson showed that when a potential difference of 5,000 volts was applied across a glass tube containing a gas at a very low pressure of about 0.00018 atm, the tube began to glow. When the potential difference was increased to 15,000 volts, a bright green glow appeared on the glass. So Thomson was able to prove that the glow was due to some kind of ray that travels in a straight line from the cathode. He called that ray cathode ray. Based on further experiment, the cathode ray was shown to have some properties. Number 1, the cathode ray can travel in a straight line and cast shadow of opaque objects placed in their paths. The cathode ray are composed of only negatively charged particles. The cathode ray are capable of producing mechanical motion, and then the cathode ray are identical in nature and in the ratio of charge to mass, irrespective of the nature of residual gas. So generally, Thomson model helps in can be called cathode ray experiment. So J.J. Thomson carried out what is called a cathode ray experiment, and that led to the discovery of cathode ray that has properties that I've mentioned the other time. Now, in the course of his research, he now came up with his own model of atom, which is called a plum pudding model or a watermelon model. You will see in this, you see a watermelon. Inside that watermelon, you are going to have the seed, which are black. They are the electrons, and they are negatively charged. And then inside it, we have a spherical cloud of positive charge. A spherical cloud of positive charge. This is how a Thomson model look like. But we can look at it in an advanced way. The plum pudding model of J.J. Thomson. In the model, you have a positive charge nucleus surrounded by electron. Now the positive sphere are what is called the pudding. They are surrounded by negative electron that are called plums, which are dispersed throughout the process. So for Thomson atomic model, atom is solid. There is no empty space. Some of the key highlights of Thomson model is that the atom is solid, no empty space. There is no nucleus in the Thomson atomic model. Then the positive charge in the atom is uniformly distributed. So this is the summary of Thomson atomic model. Don't forget, like I've said, for J.J. Thomson carried out what is called a cathode ray tube experiment, and which led to the discovery of cathode ray, which were later named electrons. So therefore, J.J. Thomson discovered electrons. J.J. Thomson discovered electrons. In his cathode ray tube experiment, there is production of beam of negative particles, which are called cathode rays, that have some properties that I mentioned the other time. And in this process, he discovered electrons, which are negative particles within the atom, and he also developed a model of an atom called plum pudding model. The plum pudding model, and the summary of his atomic model is that atom is solid. There is no empty space. There is no nucleus in that model, and of course, the positive charge in the atom is uniformly distributed. You will see that Thomson cathode ray experiment here, where you have a stream of electron that is attracted to a positively charged plate. You can see it here, a stream of electron positively attracted to a positively charged plate. Okay, so this is generally the summary of J.J. Thomson experiment, and the next person was Ernest Rutherford. Ernest Rutherford is a student of J.J. Thomson. He is a Nobel Prize winner. He carried out an experiment called the gold foil experiment. He carried out an experiment called the gold foil experiment, and is the one that discovered the nucleus. Don't forget that in Thomson did not discover nucleus. In Thomson model, there is no nucleus. There is no empty space. The positive charge in that plum pudding is uniformly distributed, and then of course they are surrounded by the cloud of negatively charged, and then the atom is solid. Now in Rutherford's model, Rutherford discovered the nucleus and give it a characteristic. He discovered that the nucleus is dense and is have a positive charge and is at the center of the atom. This is the summary of Rutherford's work, that when he discovered the nucleus, that the nucleus is a dense positive charge found at the center of an atom. And then he proposed what is called the nuclear model. He proposed what is called the nuclear model. In his gold foil experiment, you can see the gold foil being bombarded by alpha particle from a radioactive source. And from that alpha particle, you notice that in the experiment, you can see he was expecting that the alpha particles were going to be penetrating directly inside the gold atom. However, this was the expected result. The actual result shows that although some passed through the center of the gold foil, the gold atom, however, some were deflected. Some were deflected, as seen in this picture. Some of them were deflected. So as a result, he mentioned that something must be responsible for the deflection of this atom. So he later came up with there is a large mass at the center of the atom. There is a large mass at the center of the atom, and that large mass was given as nucleus. The large mass is dense, is positively charged, and is surrounded by electrons. And therefore, the Ernest Rutherford model was called the nuclear model because it led to the discovery of the nucleus. And then the properties of nucleus was discovered as well as dense, positively charged, found at the center of the atom, and then surrounded by negative electrons. Okay, so the Ernest Rutherford model can also be known as is also known as the planetary model. In this, is talking about the planetary model. Talks about the atom's electron cloud does not influence alpha particle scattering. The atom's electron cloud, does not influence the scattering, but much of an atom's charge, specifically its positive charge, is concentrated in a relatively tiny volume at the nucleus. That's the second postulate or second summary of his model. Number 3 is that the magnitude of this charge is proportional. The magnitude of this charge is proportional to the atom's atomic mass. The remaining mass is known to be mostly attributed to neutrons. Now, the next point is the concentrated central mass and charge is responsible for deflecting both the alpha and the beta particles that was bombarded, that was used in bombarding the gold foil atom. And then, of course, the mass of heavy atoms such as gold is mostly concentrated in the center charge region. The mass of heavy atoms such as gold is mostly concentrated in the central charge region. So this is the postulate of Rutherford. So in summary, for Rutherford model, which is also called planetary model or nuclear model, you have the nucleus, which is a positively charged, large, very dense mass found at the center. In the nucleus, there is proton and neutron. Proton is positive, neutron is neutral, and of course, it is surrounded by electrons. Now, and these electrons are moving in a circular path that are called orbits, they are called electronic orbits. So this is the summary of Ernest Rutherford model. Now, to add to it, Rutherford model atom is hollow with a lot of empty space. The nucleus is at the center. The positive charge is concentrated in the nucleus, and an electron revolves around the nucleus in specific orbit. So this is a summary of Rutherford's atomic model. Okay, in the process of discussing this model, we must put to note that now that Thomson has discovered the electron from the cathode ray experiment, and then Rutherford has discovered the nucleus, and have also shown that the proton is found in the nucleus, we must point to know that the person that discovered the neutron is James Chadwick. James Chadwick discovered neutrons in 1932. And neutrons are neutral particles that are found in the nucleus of the atom. We have explained that the other time. In the nucleus, you have the proton and the neutron, and the neutron was discovered by James Chadwick. So he also mentioned that the overall charge of the neutron is 0. So James Chadwick model is called the neutron model. It's just a revision of Rutherford's nuclear model. So we must put that to note. And then the one of the most important model to talk about was also mentioned by Niels Bohr. Niels Bohr was able to revise Rutherford model. Niels Bohr is the father of quantum physics. And then in Niels Bohr model, there is a revision of Rutherford's model talking about electron as accelerating charge. It talks about the energy levels, and his model also talk about that electron can only exist in specific energy states. So generally, Niels Bohr talk about energy levels and electron being only able to exist in a specific energy state. So in Niels Bohr model, there is a specified distribution of electron in different orbits. There is specified distribution of electron in different orbits. Bohr model suggests number of circular orbits around the nucleus in which electrons are distributed. He also thought of an atom as a tiny solar system, nucleus as the sun, and electrons as the planet. So according to him, atom is made up of two parts, the nucleus and the extranuclear part. Please take note of that. In Niels Bohr's model, one of his suggestions is that atom is made up of two parts, the nucleus, which is housing the proton and the neutron, and the extranuclear part, that is the electron moving in a circular orbit, their energy levels, and so on. Okay, so in Niels Bohr's atomic model, you have the nucleus at the center, you have the electron revolving around the nucleus, and then you have the electrons moving in a circular orbit. And in this model as well, it talks about bright line spectrum, where he tried to explain the presence of specific color in hydrogen spectrum. He also talked about a planetary model in where electrons are moving in a circular path within specific energy level. To quickly point to note, we can also talk about so Rutherford is nuclear model, while Bohr is planetary model. Okay, so for Henry Schroeder, it talks about electron cloud model, using dots to represent the probability of finding an electron in specific orbit. So in the electron cloud model, is also based on Niels Bohr's model, except that electrons orbit the nucleus in random pattern. That is what Schroeder was saying. That of course is similar to Bohr's model, but the difference is that electrons orbit the nucleus in random pattern. The regions where these particles are found is referred to as the electron cloud. The regions where they are found is referred to as the electron cloud. So this is basically what Schroeder was talking about. Okay, so far so good. We have talked about the development of atomic theory. We have looked at the foremost work that was being accepted, which is the John Dalton's work that talked about of the Bohr model, the Billiard Bohr model, and his theory, Dalton's atomic theory. We talk about the J.J. Thomson using cathode ray experiment, discovering the electrons, and talking about his model of atom. We talked about the Ernest Rutherford Ghost foil experiment and nuclear model. We talk about Nibor planetary model, and then of course talk about electron cloud model by Erwin Schrödinger. Okay, so we can quickly look at these two WAEC questions. I want you to pay attention to these two WAEC questions. The first question is, what is the structure of an atom as proposed by Rutherford? What is the structure of an atom as proposed by Rutherford? This is WAEC 2012. Please pay attention to solve the question. To look at the question very, very well and give your answer. I will want you to pause and give your answer to this question. And then the question 2 is WAEC 2019 question. WAEC 2019. The question says that you should state the important points put forward in the Dalton's atomic theory. You should state the important points put forward in the Dalton's atomic theory. And the B part of that question is you should explain how this theory, the Dalton's atomic theory, explain the law of multiple proportion. Can you attempt this question, please? Can you attempt these two questions? One is WAEC 2012, one is WAEC 2019. Okay, quickly, after if you have attempted this question, so let me also help in solving this question. You can compare your answer with mine, and of course make necessary corrections. Compare your answer with mine and make necessary corrections. Okay, so the solution to number 1. Most students are able to talk about this, but if you go back to that question, the question say, what is the structure of the atom? So you are expected to draw. So WAEC expected to draw. So that means if you have only mentioned it, you would have scored half mark. The question was about 3 marks. So the diagrams take 2 marks and the explanation take 1 mark. So it is expected that you draw the structure of that atom as proposed by Rutherford. Rutherford was talking about the nuclear model, where, like we have explained the other time, where we have a dense area which is at the center of the atom, and in that dense area it contains a positively charged proton. So inside the nucleus you have the positively charged, and then you have a stream of electrons revolving around it. That's the diagram. You're expected to draw the diagram in that question, and then to further explain the diagram, you will now say the atom has, in Rutherford's model now, the atom has a small or tiny positively charged center or nucleus with electrons surrounding the space around the center nucleus. This is how WAEC expects you to answer this question. Now the second question that was asked, you were told to state the important points. Actually, the question mentioned about 3 important points. So you can mention you are expected to mention 3 out of 5. So you can mention any of these 5. That number 1, in Dalton's atomic theory, all elements consist of atoms which are indivisible. Atoms can neither be created nor destroyed. Number 3, atoms of an element are all alike but differ from those of other elements. When atoms combine with other atoms, they do so in simple ratio. And number 5, all chemical changes result from combination or separation of atoms. So this is what WAEC is. So I expected to answer 3 out of them. And then the part B, you are supposed to use that theory to explain how it correlates to the law of multiple proportion. In the law of multiple proportion, we said that A and B form more than one compound. So to answer the question, you just say if A and B forms more than one compound, then since Dalton said atom is indivisible, so the combination of these 2 atoms will be in simple or integral ratio, because the mass of atom of each element is fixed. So this is how Dalton's atomic theory explain the law of multiple proportion. So to cap it all again, these are the summary of the works that we have done. Dalton's model talks about the indestructible particle with no internal frame. It is called the billiard model. Thomson discovered the electron and believed that electrons are embedded in positive charge pair. His theory was called the plum pudding model, or the watermelon model. Rutherford discovered there is a dense positively charged nucleus. Electron will go around the nucleus. We call this model the nuclear model. And Nibor also talks about enhanced Rutherford's model by having electrons move in a circular orbit, and it is called planetary model. And in addition to that, I talked about electron cloud model as discovered by Erwin Schrödinger. I hope you have been able to enjoy this class excitedly. In the next class, we are going to be talking about other parts of the structure of atom. Thank you and God bless.